First of all, it's a great pleasure for me or for us to introduce our second speaker today, who is going to talk to us about his experiences and work and researches as an electrical engineer, more focused on renewable energy. Javier got his master's degree on electrical and electronics engineering at Moscow Power Engineering Institute. While doing so, he decided to follow another path. So he starts his second master's degree at Skoltech, and it was focused more on energy systems. And now he's still working as an assistant researcher at Skoltech, Skolkova Institute of Science and Technology, doing his Ph.D. on system engineering. So I am now delighted to hand over to Javier Penuela, who can tell us more about the exciting work and researches that he is doing at Skoltech. Please, over to you, Javier.
Thank you, Jesus. Thank you for the introduction. I will start sharing my screen. Can you see the presentation?
Yes, we can see.
Okay, that's great. So hello, everyone. It's a big pleasure for me to be here with you. I'm very honored to be invited to this conference. I will start with a general overview of who I am. My name is Javier Fernando Penuela Rodriguez. I'm from Colombia. I'm 28 years old. In general, I am an electrical engineer. Speak a few languages. I know quite a bit about programming, machine learning, deep learning, a lot of stuff related to electrical engineering. Have some good experience teaching and tutoring. And also with the public speaking, I think of myself as good at this. Team management, and I'm a very good self-learner. In general, I'm being here in Russia for 9 years, which includes my studies of the Russian language, of my bachelor's degree, as Jesus already introduced. I already finished 2 masters, and I'm starting a PhD program. All of this here in Russia. Overall, we are going to go through my background. What did I do at Skoltech for my master's degree, which is my main focus right now to continue developing this research. I will show you the experimental setup that I created here, the experiments I did, what are my plans for my PhD, and a short recap, and then discuss a little bit the possibilities to follow academic research, especially if you are planning to go overseas. So I finished my bachelor's degree and my master's in electrical engineering in Moscow Power Engineering Institute, where I got fairly good grades. My bachelor's and the master thesis were about power complexes, so power plants based on the renewable energy, on wind and solar power, for a touristic village called El Cabo de la Vela in Colombia, which has a very good conditions for this. It's disconnected from the grid. So it was a very interesting case of study. This thesis includes everything. Well, the master thesis includes everything, the analysis from the technical point of view, from the economical point of view, sociological, ecological, soil studies, includes the resources study, includes almost everything that is needed just to kickstart a project like this. At Skoltech, my focus is slightly different. I would say that it's a good complement It goes along very well with my research at Moscow Power Engineering Institute. So in 2018, I started in Skoltech in energy systems, and my research is focused on demand response. And I want to introduce this technology to the indoor agriculture industry, which is the greenhouses and the vertical farms. As I told already, my main focus in Moscow Power Engineering Institute were in renewable energies. Now it is more in the at the grid level, at the in control, we can say. Besides that, I won first place in the Russian National Olympiad on renewable energies. This beautiful boat you see there, it was built by me and other two colleagues to participate in a regatta, which is a race of boats. So the whole design construction was on me, the other two help with construction and finding partnerships. Besides that, I also made the experimental setup on which my thesis was based, and we will see a lot of it in the next slides. I want to give you an overview of how looks the master degree here at Skoltech. A master degree in Russia, for starters, well, it would be in Russian in most cases, and there is not much freedom of choice on what you're going to do, nor in the research side, nor in the subjects you are going to take. On the other hand, Skoltech is made by MIT, so the biggest influence are the American universities. That's why we have the same credit system, the same freedom of research, the same freedom of investigation. For instance, the first two courses listed here, Energy System Physics and Engineering and Fundamentals of Power Systems, were mandatory courses. The others were not. I simply select them because I found them interesting, which were mostly based on the data science. Most of them, some power markets and regulation, and the other are just data science in very focused ways. That was my own selection. I could have selected anything else, so the freedom is very big. Besides that, I have some entrepreneurial experience. I had my small fast food business, and I also have a small company of logistics and catering for small events. Besides that, I work in a company called Tion, which is a company that is based in Novosibirsk, here in Russia. Their main interest is microclimate control. So they work with air conditioners, with heat pumps, with refrigeration systems, also with the ventilation, which is a very interesting topic right now because of the COVID situation. How you manage the microclimate highly affects how dangerous it is to be in the same building with somebody who is sick. And they were exploring a lot of different solutions, but most of them required a big increase in the energy consumption. So they found very interesting my project of trying to integrate demand response into the microclimate management. We will follow later exactly what is demand response to decrease the cost of electricity. And besides that, I've been here almost since I came to Russia, a tutor of Spanish language, which is a great way to earn some money while you are abroad. And I became very, very good at this. The main motivation of my research of focusing in the indoor farming industry, which is a not very well electrified industry, is actually the electric cars. Electric cars were seen no so long time ago as something that is not related to energy systems at all. Yes, people were thinking when they think of cars as mechanical engineering, as petroleum engineering, or something different. Well, the same happens with agriculture. People think of petrochemics, people think of land use, of ecology, but they don't really think about the energy systems, even though agriculture is very energy intensive. Nowadays, for us, it's obvious that we are going to integrate cars into the electrical grid. And the same will happen with the whole agriculture industry. So the aim of this research is to make more affordable this integration and then foster the integration of the agricultural sector to the electrical grid. The first concept to talk about the research I need to introduce is a demand response. So whenever you're talking about any market, you have a demand, which is what people want, what people need, and you have the offer. So what is available to be sold. You can, as a producer, control very well what you can offer to sell. But there are these different markets that doesn't allow you to accumulate something. For instance, if you sell iPhones, you easily can make all the iPhones of this year in about a few months and store them. You won't have a lot of issues having them stored. It may be a little extra cost, but something you can do. With electricity, on the other hand, it is very complicated and expensive to store the electricity that the country needs. So you need to balance how much are you producing with how much is consuming every single second. That is expensive and that is difficult. And that is especially difficult when you're integrating renewable energies. Why? Because you cannot guarantee what are you going to get the next second, the next minute, the next hour, or the next day. You can have certain level of certainty, but you cannot predict fully. So when you have a big penetration of this kind of energy sources, the grid becomes more uncertain. And to balance the grid, this demand and this offer of electricity becomes a bigger task and it becomes more expensive. So not only regulating what you can offer as a grid operator, as power plants, yes, is enough. You also need to incentivize the customer to be more predictable and to cooperate with you. Yes, so if in certain moments the customer is doing something that is not optimal for the grid, you need to learn how to incentivize him to do something that is optimal for the grid, and therefore is going to be better for the overall economic of the grid, for you as the producer of the energy, and for them as the customer of the energy. In general, you can have three different tactics. The first one is called load shifting. In almost everything, for instance, you can think of transport, of restaurants, of, electricity as well. You have two peaks during the day. The first one is when people gets up and gets ready to get to work. So they use transport, so they eat breakfast. And the second one is the evening peak, which is when people are going back home, cooking, gathering together. During these times, you have the most intensive use. These peaks are very expensive because during the peaks, to keep balance the grid, you need to connect whatever you have available. That includes the less effective power plants that usually are less ecological and also are very expensive. so you can imagine this a little bit as the transport system. Yes, during peak time, it is uncomfortable for everyone because there's no enough space in the buses for everybody, and you will need more of them. And because there are too many, you get extra congestion on the streets, and this chaotic is not good for anybody. And also, it's not very ecological because you have more buses there. It's not good for the transport system because you have more conductors, more buses again. And for you, it's not comfortable because you're packed in a bus with a lot of people. Yes? The optimal way would be that everybody goes by little to work and comes back home little by little. Yes? So you have like a straight line during the whole day, you have constant. That would be optimal, perfect, ideal. So that's what we're trying to achieve. And with one of the first tactics is that you can tell people, okay, if you consume electricity in a time different than the peak time, for instance, during the night, then the electricity is going to be cheaper. There are many industries for which the price of electricity is the main cost of their production. So for them, if electricity is, let's say, 50% of your total cost, and you can get it 50% cheaper because you're consuming during night, well, that's a big decrease on cost that will make you more competitive in the market or will increase your revenue. So for your company, it's going to be great to do that. And for the grid, it's also going to be great because they can redistribute the resources in an optimal way. So that's the first one, load shifting. The second one is peak shaving. This one is usually done by direct signals. Yeah, so the first one, you change the rules of the market. You say during the night, electricity is cheaper. And people shave by themselves. They will go from consuming electricity during the day to go to consuming electricity during the night by themselves, only because they know it's cheaper. Peak shaving doesn't work like that because you don't really need it all the time. Only when the peak, for some reasons, is very high, and then electricity becomes very expensive, and you have to use a lot of plants that you don't want to use. In that case, you can agree beforehand with different companies, and you send them a signal, and they will disconnect that part of their load that you agreed beforehand during that time. So you reduce the consumption. Again, the main goal is to balance everything. So to increase the power plants during peak time or to reduce the peak is equivalent, is the same. Well, happened that this peak shaving technique is by far cheaper than building new infrastructure. It's calculated, and this is just estimations because it's so complex that it's very difficult to really estimate the economical value. But it's calculated that it is about 100 times cheaper just to pay people not to consume electricity during peak time than to build new power plants, new transmission lines, new distribution lines, yes, new transformators, new substations, and so on. Yes. And in different countries, like in the UK, where you have a lot of wind energy or a lot of solar energy, you can also have moments when the consumption is lower than the production. And you can allow this energy to go to waste, to store it if you have storage enough for that, which most countries don't. And I would dare to say that no country does yet. The other option is to incentivize people to consume more during that time. So you beforehand, you can also agree with some companies to receive a signal when there is a lot of extra energy in the grid, and they will use this energy for very cheap prices. So you see, demand response is a lot about markets. It is a lot about how you will manage to incentivize the people to consume the electricity in the way that is optimal. Yes, no, whenever you want, but whenever is optimal. So this is demand response. In general, we call it implicit. It is load shifting because it is implicit in the rules of the market. You don't have to communicate directly to the people. And explicit when you send a direct signal, that will be peak shaving and valley filling. Our second main concept is indoor farming. This industry are industrial greenhouses, just not the small greenhouses somebody may have in your small farm, but in the industrial size ones, and the vertical farms. In general, electricity is about 40% of the cost of operation. In all Europe, USA, and also China, so most of the countries in the north, this is very important because during winter they cannot produce their own food, and that disrupts their autonomy, and that is not good for the economy, and also it is not good for the political point of view, for the stability of the country. So Europe and China, Russia a little bit, and USA, they are investing heavy money into increasing the quantity of greenhouses and vertical farms. As I mentioned already, electricity is about 40–50% of their total cost. So if participating in demand response, they can save some money, as this is the main cost. They can drive very low the price of their vegetables or their fruits, and therefore to become more profitable, to grow faster, and to bring us better benefits. So this industry is actually one of the most ecological ways to make agriculture. Besides the energy consumption, in every other parameter is more ecological and less resources hungry than other kinds of agriculture. So the aim of the research is to put these two pieces together and to see if the grid can benefit from the greenhouses participating in demand response, and the greenhouses can benefit from this opportunity that the grid gives them, and reduce their cost. There is one problem to check that. The big question is what will happen with the plants, because demand response will demand not to have optimal lighting, not to have optimal temperature management for the plants. Yes, so we need to understand, are they flexible? Are they okay? Will they grow as good as before if we sometimes disconnect their light, if sometimes we disconnect the refrigeration or the calefacción? Yes, that's what we need to understand to know if they can participate. The question is about flexibility. And to understand if this load, this kind of load, which is this industrial greenhouses and vertical farms, is flexible, well, we needed to grow some plants and to see what will happen with them, because the plant is their final product, their vegetables. So if these vegetables grow as well as without using demand response, then they can use it. And they will use it because the savings are substantial. If they don't grow as well, we can see how much stress we can put in these plants, so how much they can participate. Yes, and also find an optimal way to reduce anyway their electricity price. Again, we're not talking about reducing electricity consumption. In general, they will consume the same quantity of energy. They will just do it in a more optimal way for the grid and be compensated to help the grid to balance out. To prove that, we had to make our own vertical farm. And this is our setup. So we developed this setup, which has autonomous lighting. It is built inside of a phytotron. A phytotron is like a greenhouse made for research and experiments. So we have total control of environmental parameters, total control. We can change temperature, we can change relative humidity, CO2 concentration, the quantity of photons that we have in the getting to the lift of the plants, the watering we can change all the parameters as we please. So it is a great example of how to study it. In general, we build the whole thing inside of the phytotron because that allows us to have a first version of it without worrying much about the microclimate control. Microclimate control is a very expensive thing to build and is something to be careful about. Yes, so we started with this first step, which is the lighting, the watering, and the sensing part. And then later we will take it out of the phytotron and add an independent microclimate control for it. So more or less, this is how it looks. You can see in the first photo, well, in the first image, a model of more or less how it works. In the second one, you can see an overall of some plants growing there. In the third one, the lights. In the fourth one, you can see the watering system along with some plants, and there's a sensor there in the photo. And the last one is about the ventilation. Everything was in capsule because we need to control the light just to know how it is the plants are affected by the light distribution during the day. I will talk about that a little bit later. The setup was developed fully by us. So in general, we took some standard microcontrollers, which are based on the ESP32 microcontroller to make the whole sensing part and the controlling part. It is fairly simple, actually. We can say that there's nothing very interesting in this part. The whole thing operates through a central server, which is connected via Wi-Fi. This is good enough for the control system and the sensing system, not good enough for the cameras because they are not very stable. We can reset and make the sensing system and the control system to go to sleep from the Wi-Fi system, which is operated from a central computer, from a central server. But the cameras are not stable enough for that, so they had to stay awake the whole time. For this communication, we use the MQTT protocol for everything, but for the cameras, because MQTT doesn't support the big files. So we made a small server inside of the camera with a static IP, and we automated the download of the photos that are taken via the server from the camera to the central server. This is a bit problematic because it is only one-way communication. So if something goes wrong, it is not capable to reset the cameras. But once they are stable on, so once manually you make sure they're on, they will stay stable for weeks. So that wasn't a problem in our case. Besides that, we had also some professional sensors, which were in charge of the environmental parameters. So the ones we made are for soil parameters and for the light. For the environmental parameters, we were using Libelium sensors. Libelium has this product called WASP mode. Very interesting thing, very easy to use, and very robust. You can use it in almost every single thing. And it also has some Wi-Fi modem called Libelium Meshlium, which is equipped to be used on the street. Also very interesting device. It's capable to be autonomous. So you can send the information directly to the server and have a copy inside of the router in a local server. So the structure is very interesting. It's very simple to operate it. Our server is just in a Raspberry Pi. So it is very inexpensive system from the control part. The lights and the structure itself is not that inexpensive because you need quite a lot of power for this kind of tasks. So what was the experiment? We download the early spot prices of electricity, so the historic data. We use it in an optimization task just to get how would look like the light if we minimize the cost of it. Instead of optimizing the plant growth, we are optimizing the electricity price. Yes. And you can see in this heat map more or less how it looks. So you have the night in the middle of the day. Yes. Then you have the light, and then at the very end, you have this very noisy part. Yes. So I want to make clear why this is interesting. Plants, as humans, they have something that is called a circadian rhythm. A circadian rhythm means that almost 24 hours internal clock. Yes. So the same way that you go to sleep almost every day at the same time, that you get hungry almost every day at almost the same time, the same happens with plants. So imagine that somebody is coming in the middle of the night and waking you up and then sending you to sleep again with certain randomness. You can say that in general, it is constant, but there is a noisy part, a random part. And that's what is interesting. This random part is very inconstant, it's very non-consistent. Will that affect the growth of the plants? If you imagine it as a human being, well, most likely you won't sleep well, most likely you will have problems. You won't die, but you won't be in your optimal shape if every single day you have a different sleeping schedule or a different time for eating. Yes. So it is more or less the same. Then using this minimized consumption pattern for the light, we created the optimized control data for the lights, and then we started growing plants on them. And to see, we had different genetics for different genetics, and we had also 2 groups per genetic variety. Yeah, so the control one and the test one. So one growing normally 16 hours, and another one growing also 16 hours, but with this inconsistency that the demand response made to the light. So we were harvesting 5 plants of each group every 5th day after the day 15, when the plants were more or less grown, to see that affects or not. So we have one group to compare the other, and to see if one grows worse or better than the other. In general, you cannot make this comparison just by having some average number. You have to make an analysis of variance, or at least a linear regression to understand if you can fit the data. Then it will tell you if the groups are different. So analysis of variance will tell you, yes, you have differences. No, you have no differences. Yes. But it won't tell you what are the differences, and it won't tell you where. To understand where, you need to make a post hoc analysis. There are different tests that are very well suited for different cases. So in this case, we use the student Newman Q's test. We program all of this in this language called R, and we generated some plots so you can see them. For instance, here you can see one moment where all the plants in the control group were growing worse than the ones on demand response. So demand response looked better. Yes, we had this trend temporarily. We think it was based on some noise because in the other replicas, in the new experiments, making the exact same experience more times to check if everything was okay, we haven't seen this trend. But in general, we found out that all of the experiments shows that demand response can be used. Why? Because it doesn't make worse the growth of the plants. And so once we understand that the plant doesn't grow worse, we can check if there's something we can optimize there. Yes. So that's the next step. Also, it's important to look that there are different kinds of plants, and each one of them needs to be tested separately. So the one we tested were green leafy plants, such as lettuce, some such as rucola, some such as, what other example of them are? Different herbs, yes. These results are valid only for them. When we have flowers and fruits, it looks very different and it need to be tested also separately, which we will do. In general, I include this part, which I think is interesting. When you try to start your PhD, you will have a plan, and you will show this plan to the committee during your interview for the PhD position. And believe me, everybody, including yourself, will know that this plan is just a very far away picture of what is going to happen for real. Yes. A very good example is that during my first year, I was expecting to upgrade the experimental setup to the 2.0 version, where we have a full microclimate control independent of the phytotron. And that's not going to happen right now. And also explore different kinds of irregularity on light. That's not how it's going to look right now. Immediately, we're already publishing a paper. And then we're going to move into the control systems for a second paper. And only then, it happens to be during the second year, we're going to go back to the experiments. Yes. So very easy. This schematics breaks out, and you as a researcher need to be flexible enough to cope with it and to redistribute your tasks in such a way that during these 4 years of PhD, you are able to do everything. Yes, even though it won't come as you expect it will come. Right now in the world, the research that is more valued, especially in young universities such as Skoltech, is a multidisciplinary research. Now, why? Because when you are in one field, let's say Internet of Things, yes, there's a lot that's already done there. So to improve there, you need to make a very, very specialized research, which most likely will be difficult to do with the resources of a PhD research without a very specific and generous grant. So multidisciplinary research offers you to find these spots in between different disciplines that are not yet fully explored, just because they don't really fall into the scope of any of them, of any of these disciplines. It falls into the scope of several of them. Yes. So, for instance, this research that I'm doing is not especially complex, but it is very new because it's a question in a place that there was not made this question formally before. There are different enterprises that they do participate in demand response, having their own greenhouses, but there is no scientific literature about them. We don't know how optimal it is. We don't know how it works. So if, for instance, you working for one of these companies want to do this, you don't know if you can because there are no papers about it. Yes, well, we are formalizing this knowledge that somebody has, and it is closed because most of these companies, they work with a lot of secrets, and helping a lot of more companies to introduce these technologies by themselves. Yes. So more or less that's what does this multidisciplinary research. It allows a lot of pieces that maybe are not the most complex ones, maybe they are not obvious, yes, but it allows to put them together and to take them directly to the industry. And that is very important. If you want to make some research that it looks valuable for universities, I would recommend you to be either very focused, very scientific, either very multidisciplinary, and very industry focused. Yes, I would say these are the two main paths. You need to show yourself in one of these two to be able to make a strong research proposal. This kind of research is not unique of us in Skoltech. Also, the University of Montreal has a similar research, the University of Manchester, the University of Southern Denmark, I'm sorry, I'm not very good at pronouncing these names, Wageningen University in the Netherlands, and the LUT University in Finland. And actually, this research of what universities have something similar was done very shortly. I'm pretty sure that with a lot of more effort, I can find more and more universities that are interested in integrating the farming industry to the electricity grid. Now, if I still having time, yes, I do have time, yes?
Yes, Javier, do we have time?
Okay, I would like to make you some recommendations, yes? I want you to see my presentation as an example of what you can do as a researcher, yes, in the academy. I would say that my university is a very good and actually a bright example of what a young university looks like in the world. Recently, my university, which is here in the background, actually, is this beautiful wooden building, which is huge, by the way. We got to be the place number 65 in the world of the young universities. And the journal Nature made this ranking. So of all the universities in the world that are younger than the 50 years, we are the 65. And I have researched several of the other ones. And you can see this trend. If you want to go to a young university, and I recommend that a lot, you will see that the standards are very high. Yes, they will demand a lot from you, but the privileges are also very high. For instance, I have here a salary that is more or less twice the minimum wage in the country. And I have several benefits as the transport benefits, housing benefits. I can still also work here. I can also have grants. If I make publications, I get more money. Actually, for instance, there is a program where if you find a second PhD scholarship in another university, you can merge these two scholarships together. So Skoltech plus whatever other university. So doing one research, you gain 2 PhDs. Yes, and that is very important, this kind of flexibility. So if you're looking to go to the academy for masters or for PhD, I will recommend you to keep an eye on these young universities that are rising very fast, because they have the resources to cope with these non-standard ideas that you may have. Now, if you see that your ideas are very mainstream, yes, that what you're proposing is to do something deeper in a field that is not in a very innovative way, just to keep going forward in a direction that the industry is already going, then better go for one of the well-established universities. Yeah, so if your focus is more on the industry, on doing something that is kind of new, kind of innovative, maybe into doing your own company later, I highly recommend go to one of the top young universities in the world. To access to them, maybe it's not as difficult as to access a very prestigious university. For instance, I'm pretty sure to access a Skoltech is by far easier than to access an MIT. But we cooperate in a lot of projects together. For instance, currently, I'm cooperating in one project with MIT, and we are postulating for a grant. If I get it, if we get it, we will be able to travel to each other. So the guys from MIT will come to our lab for a few months, and then I will go, because I'm the representative from this university in this project, I will go to MIT for some months to work in the project. So these universities have very strong connections. Yes, you can do a lot. They have no big restrictions with money, which is a big deal in the well-established universities. If you go to a place again as MIT or Cambridge or whatever, money is the big question. You will spend a lot of time finding money. In these new universities, that is not such a big problem. You will spend more time trying to give results, making your research, and also publishing papers. So that is important. What is important, let's say you already found the university you want. Before starting contacting the possible supervisors, which I highly recommend, don't try, well, try if you want, but your results won't be as good if before trying to get a scholarship, you don't contact your prospective supervisor. If there is somebody who is already willing to work with you inside of the university, the likelihood of you getting the scholarship is very high. If you don't know anybody and you didn't try to contact via email to talk about research or something like that, any of the professors beforehand, well, the guy who did contact them have advantage over you. So I highly recommend, if you find a university or several universities you want, you like, you think that they have the research you want to do, contact the supervisors, talk to them. This is important because they will help to influence the committee so you can get the scholarship easier, number one. Number two, you get to know what kind of person of people they are. That is very important. You are going to work with them for 2 or for 4 years, depending if you're coming for master or for PhD. So you need to get along with them. If there is a very neurotic person, the kind of a personality that is totally not compatible with yours, doesn't matter if he's a top researcher, you won't have a good time doing research. And believe me, you will drop academic research. So contact supervisors, prospective supervisors beforehand, so you grab an idea of what kind of person they are. Other thing that of course is important is to Google them. Here I want to show you, for instance, what appears if you Google my supervisor. Well, my supervisors. I think I want to. For instance, this is one of my supervisors. As soon as you Google his name, Laurent Gensvittel, you will get one of the first links, Google Scholar. If you find him in Scopus, Google Scholar, or Web of Science, you will see a lot of what they have done. Yes. And for instance, you can see how he has a lot of papers very well cited. 300 citations in one paper, that is a lot. If you get 10 citations in one paper, it counts as a good paper, especially if it's in a good journal. So if 10 is good, 300 is excellent. So you can see the quality and the quantity of publications. Yes? If you are working with them, you can expect to be part of these good numbers that will foster later your career in research. If you are aiming to get to a lab and you see that the professors don't have any publications, that you cannot find them in internet, while you work with them, nobody will find you also. And that's a big problem, especially if you're aiming to work for some time in the US, in Europe, because for them, how visible your research is, it's everything. Yes, so if you have this kind of good numbers that will help you to get better jobs, to be visible, not only for the academy, also for the industry. This is my other supervisor, the same thing. You Google his name, second option, Google Scholar, and you can see also he has very good numbers. He's a bit younger, so his numbers are slightly smaller, but you can see how constantly they are growing, how he's publishing more, how he's getting better quality. If you get one person like this to be interested in your research, you can be sure that your publications are going to be more successful, that they will teach you the necessary insights to make good publications, the necessary insights to sell your research, so you can do better things in future. Yes, because all after all, especially if you come for masters, you are here to learn. During PhD, you are supposed to be able to also have a real output. Yes, to make a real contribution to science. But all of this is also a very long path, and you will need a very good hand to guide you. So once you understand that this person has the aptitude, has the qualifications to guide you, because that person has very good results himself or herself, then you can start talking to them, understand that if you can work with them, if you get along with this person. And once that happens, you will have a big advantage over other candidates to get a scholarship in this kind of place. Yes? So that's what I would recommend you. This is talking about how to get this here, how to get to get a master somewhere in the world, and also how to get a PhD somewhere in the world. Once you get it, you need to be very active. Yes, if you're going to a more traditional university, you need to be very active to get funding. Because it is a big problematic. A lot of universities will give you not a full scholarship, so you will need to find some money on the way, and of course that won't allow you to focus fully on your research, which is a problem. Yes, but it's a very interesting challenge for yourself at the personal level So if you find this kind of scholarship, don't think less of it. It's just a different kind of challenge. Maybe the biggest challenge is not only in academy, it's also on the personal level, which is also great. Yes, you just need to understand it's different. When you go to these new universities that are very successful, you can look for it in Google. Nature Index is the index that the journal Nature made of the newest, best universities in the world. Look for them, try to find a scholarship in them, and then you will have less problems in the personal level with your own money, your own finances. You will be able to focus more on the research, which is great. Yes, but you also need to make use of all these academic opportunities you can have to get internships. These universities that are really trying their best to get a lot of contacts in industry. And if you help them or they help you to use these contacts, that will work a lot for you in the future. And also try to get academic mobility. If you want to make very strong, very good research, you need a good team. You need a diversity, big diversity in your team. So don't be shy, write everybody. Whoever is doing something that interests you, try to get in touch with them via email. Yes, you won't lose much time. You will learn to do that more or less quickly. After, I don't know, some 20, 30 emails, you will see how now you became more friendlier, more interesting, and you will start attracting more people to your team that will allow you to go abroad again. Yes, during a master's, during a PhD, even if you are abroad already, you can also move to a third place. And that is great. You need to make a big network of researchers for yourself. You need to understand that the local network of people that you will find in your university is never enough. You need to be as global as possible. One more thing that I would say to finish is that after you finish a master or a PhD, you need to try to be careful when looking for a job if you want to go outside of the academy, if you want to go to the industry. Because depending on the country you want to work in, a lot of people won't be able to pay you the corresponding salary for your level of studies initially. So try to have some perspectives to understand where you want to be the following years, so you can plan when you go to the industry to work and when you go to the academy to make some research. I think that a very good professional will have these two things in their life at different moments. Will be partly in the academy, partly in the industry, and that is going to be great. Just a very few of them are going to be only in the academy or only in the industry, and that is great as well. Okay, thank you for your attention.
Thank you, Javier, for the terrific talk. First of all, we have one question in the chat, and then we will move forward with the audience. Let me read it. The question is about the energy. What happened to the energy when plants are already degrading? How will it affect an electrical network in a house?
I hope with the word plants, you mean the power plants, yes? Or you mean vegetables?
Could you clarify, please, Adrian, what do you mean by plants? Let's wait for a minute while he is writing down his answer.
Yes, but,
another question here, while we are waiting, it is about the boat that you present in the Olympiad. what approach or which approach did you take to design and construct that boat?
Yes, well, it was very interesting. Actually, at that moment, I wasn't very good at programming and using any kind of things like that. Let's say advanced computational tools. So the optimization of this boat was pure brute force. Yes, what we did, it was to take all the possibilities. Yes, you can have a boat that is as light as possible to be as fast as possible. Yes, or you can have as powerful as you want. Yes, so as powerful as possible, which means heavy duty. Yes, so it's more or less as the train. You can have light trains and heavy trains. We try to calculate how will work the aerodynamics and how will work the power consumption on these two options, and with different configurations. So also we just simply make some research on Google. So the most frequent shapes or normal boats, yes, and study all of them in these two configurations. And we went with the one that had the best output, so the less power consumption and was the lightest in this case. So let's show the photo again, because yes. So once we calculated the aerodynamics, we understood the materials that we needed to use, and from the options available, we took the most similar. The shape, we also understood it from the aerodynamic calculations. The calculations, we made it just following the instructions of academic book on how to calculate the aerodynamics of this kind of stuff. Then in that moment, we understood the approach should be as light as possible. Yes. So we made we took the slimmest boats we could, and the solar panels are frameless and they're also flexible. Yeah. So each one of them weighs about a kilogram and a half, which is nothing for a solar panel. We also calculated to what angle the solar panels should be, which happened to be 0 because it was in summer. And also the power, in this case, we calculated the power plus the batteries, what is the weight they're going to have and how they're going to affect the power consumption overall. Yes, so we maximize the quantity of energy we could harvest using the solar panels. And the batteries and the motors, which were the heaviest part, we optimized it using the maximum solar panels we could. And more or less that's the approach we used to make the design.
Excellent. Thank you for answering. I think, let me see if we got a replay.
Well, I would say that the question makes sense only if we're talking about power plants. Okay. But as in the exposition, I had vegetables and power plants. Things may get a bit confusing. So what means to have a degrading power plant? It means a lot of stuff. Yes. For the electrical network in general, it means extra expenses. Yes. So imagine a power plant will be worse only because it's older, even without being degraded, while technology moves forward and new technologies are more efficient, therefore more inexpensive, which is great. Yes. So even if you don't have degradation in the power plant, this power plant is not optimal when it is old. Now, when you're having this degradation, the efficiency of the power plant is going down. Yes, if you want to keep up with this power plant, you have to make the extra investment to recover the power plant to avoid critical failures. So as you can see, all I'm talking is about expenses. These power plants, when they start degrading, yes, they become expensive. They don't become dangerous. They don't become less stable. Because while all of this is happening, this happens slowly. And then you have to invest and invest and invest again if you want to continue using it. So they become very expensive. A very good example of that is that here in Russia, I'm sorry, I forgot a bit the names, so I mix them up. The 8% of the all power plants in Russia are used only 7% of the year. Yes? But anyway, the grid needs to pay for them because they are there. They are ready to produce energy, and just to be there, they are going to be paid. And whenever they're producing energy, they are going to be paid as well. But as they know that they are going to be used so little, well, they sell very expensive energy as well. Yes. And usually this is the kind of plants that you can use and load very quickly and take the load out very quickly as well. And usually they are very contaminating. And just to have them, it's expensive. You don't use it much, but you have them as a dead weight. You have to keep with them. But not only with them. Just to have them demands you to have extra substations, extra transmission lines, extra distribution lines. Yes, so to have this degrading power plant is not only expensive by the power plant itself, it is expensive by the rest of the infrastructure. And because it's so expensive, it's easier just to pay people not to use that energy. And that's what demand response is about, because this is very expensive. But in effects of quality or anything else of the energy, it doesn't affect. It just will make your energy more expensive.
Excellent. Thank you very much, Javier. I don't know if someone of our audience have any questions to ask our guest. Let me verify the chat if we got some other questions. How do you plan to take into consideration other plants or other kinds of vegetables just by experiments, or do you plan to get some mathematical model for that?
Yes, my first approach was try to modeling them. And biology is a very noisy science. That's something that I learned from that. So you cannot really model them. Even using machine learning, any model you make of them is not clear and good enough. It's not complete enough. Yes, it's like trying to model people. You can model maybe some simple behavior, but you need a lot of data for that. Yes, so you need tons of data to model simple behavior. And so that approach is just not viable, unfortunately. So the approach is should be experimental, at least for now. If demand response becomes popular in this industry, the industry itself, by producing their own vegetables, will generate tons of data. And actually that will help to create better models of how photosynthesis works, for instance. Mm-hmm. Yes, of how the environment affects the plant, because absolutely all the parameters are correlated between themselves. And they are noisy. Yes, and when you add the chemistry, which affects it so much, so slight differences in the quantity of potassium, let's say, will change totally how the photosynthesis happens. Mm-hmm. That's why it's so difficult. So it should be experimental. These kind of experiments are a proof of concept. Yeah, so I'm proving that yes, it can be done and it is economically good. The calculations, by the way, were that this industry will save up to 27% of the total of their total energy cost. Yes, which means about 15% of their total production cost. So it's a big saving.
So you're claiming that your model or you propose will reduce their total cost by 50%, right?
15.
15%, right?
Yes, 50, unfortunately, is way too much. I'm still dreaming of that.
That's awesome. Yes, incredible. And what about, so therefore you have to model or you have to experiment with each plant, right? So if you are roses or if you have tomatoes or something like that, you have to experiment with each one.
More or less. So this green leafy plants, so we can make some small groups. Yeah, so green leafy plants and photochronologic, I believe is the word, flowers and non-photochronologic flowers. Yeah, so far that are the groups. For this first one, which is the most simple one, it is enough to test different genetics, just to understand that you didn't by chance get the only genetic that responds well. Yes, so to understand that these effects are general for the whole group, for all these green leafy plants. When you go to flowers, it's the same. You have like a category of flowers. You select a few genetics of these. You test all them together. And if you see that all of them respond more or less in the same fashion, then you can say that you have a representative group and that it works for all the plants in this group. Now, if it doesn't work optimally, so if you have some side effects, then you will have to study each one of them individually to get to optimal parameters, to optimal participation.
Okay.
So I hope that doesn't happen.
Understood. Very clear. Thank you. One more question here we have is about your setup. How effective it is? So what will you change in your setup to say optimize the data collections or the energy consumption in your setup? Because it is another system that will generate some waste of energy, right?
Oh yes, a lot. The thing is, I was trying to limit the budget consumption, so I didn't want to spend much money because I understood that these kind of things, they work by the agile method. Yes, so, I guess most of you are familiar with SpaceX. Yes.
Yeah.
They don't use the same rocket twice because they collect all the information they need next rocket. Yes. Here should be a little bit the same. The first vertical farm I built, of course, is full of flaws. I could make you a huge list of them. Yes, but that's why I didn't want to spend much money on them because I knew that I will need to make big changes later. Now I have an idea more or less of what I can save and what I need to change. And from the data collection system, I will never recommend anyone to use these cheap circuits, even Arduino, because they are not very stable. Yes, they are very dependent on a lot of very capricious factors, and then when you get the noisy data, you have to spend a lot of time making data processing and data pre-processing, and even with that, the certainty of how the data reflects the real environment is kind of low. So for very serious sensing tasks, I won't recommend people to use Arduino and chip sensors. I will recommend to use, for instance, Livelium. Yes, they have very
Okay.
expensive sensors, but they are not that noisy. Yes, but for a first iteration, just to understand how you are going to program everything, how you are going to connect stuff, to get familiar with protocols, to get familiar with how things work, how things should be connected, how things will grow in my case. Yes, try to make a first iteration, a first prototype that, yes, will be cheap. You know beforehand it's not going to be the optimal. Maybe something of it you will recycle later, but you will need to introduce heavy changes for the second version, for the third version.
Yeah, awesome. Here we have another question about the previous one, that's about the model. Wouldn't you use reinforcement learning to generate the model or to learn the model?
That's in the plans, actually. Here, when we are seeing the optimization, yes, this optimization is based on historic data of the market, yes. So imagine that you want to optimize for the future time. I mean, the experiment use perfect data, which doesn't exist in reality. In reality, you have this imperfect data. You can have an estimate of what is going to be the price of electricity for the next day, yes, but you don't have the full data. Now imagine not a vertical farm. Now imagine a greenhouse. You have even more uncertainty because you don't know how much sunlight you're going to have. Yes, you have an
Yeah,
estimate again, but you have no certainty. So you do need to have a very good control system. And as all these greenhouses are so individual, because this kind of equipment is the things that are very individual, the best option is just to have a basic, well-done control system that over time, using reinforcement learning, would learn a better policy of how to operate this very specific greenhouse. The same happened with the vertical farm, but only when we are talking about the microclimate, about the temperature, about the humidity, the CO2.
yeah. You talk about a control system. Could you please specify what kind of controller or algorithm did you use? This is the first question. And the second question is, what kind of technique in optimization did you implement?
Well, in this case, I don't have a control system yet. Why? Because for the experiment, I don't need it. Yes, I
Okay.
just have this server with the data that every 5 minutes being what to the controller. What is the current parameter for the next 5 minutes? Yes, I did it every 5 minutes because again, it is not stable. If something goes wrong with the connection, then I will miss 5 minutes of the time, no more. Yes. So far I don't have a light control system. The problem with that is that these systems should be very complex. In general, there are two kinds of systems. One which is based on thermodynamics. So you try to describe the thermodynamic laws that work inside of the greenhouse, and then you use that model to minimize something or to optimize something. Yeah. So you use these equations to, for instance, to maximize plant growth in a shorter time, let's say. Yes.
Yeah.
And you for that use experimental data, and you use these laws, and then you put them in an optimization problem, and you see what do you get. More or less, that's how all the big greenhouses work nowadays. So this model also can have submodels, different submodels, one for energy consumption, one only for protection systems, and so on.
Yeah.
In this case, our
Perfect.
optimization problem was a very simple one. It was just a linear optimization problem. Because our boundaries are per day, we assume that we cannot transfer the light from one day to another day. Like the plant needs daily 16 hours. So that makes the problem very simple. So I solve every single day as a linear optimization problem.
That's it. Perfect. Excellent. I don't know if we have any other question for our audience. Please, you are free to ask any kind of question about the topic.
Also, if you have questions related to your perspectives for the future for masters or PhD, that's a good question as well.
Talking about that, could you please speak a little bit more about the opportunities that Skoltech offer to masters for bachelor's degrees or bachelor's graduates?
Yes, yeah. So to come to Skoltech, you will require to pass some interview, the English exam, some also online exam, and once you pass everything, you come here to Russia. You will get housing, you get a good salary, more than enough to live comfortable, to save some money even. In general, the university is demanding. Don't recommend and actually with this kind of universities, the more benefits you get, the more the university is going to squeeze you. So when you get into a place with a lot of benefits, be sure you won't have the time to have also a full-time job, let's say, or to just to travel a lot, maybe a little, yes, but not a lot. The university will give you very quality courses. In the case of Skoltech, we have very good professors of all around the world, which is great. And they have contacts all around the world as well. And the university is very willing to finance people just to go abroad. So you can come here for a master's, which is 2 years. And the first year, you study most of the subjects you will require. And during the second year, you just go 3, 4, 5 months to somewhere, to Spain, to Italy, to France, to the UK, to the US, totally financed by the university. And for the university, that is important because that helps the university to publish together papers with teams from very prestigious universities. So for them, it's an investment on their own prestige. That's number one. Number two, because as soon as you get this kind of experiences, it's very likely that you will continue cooperating with Skoltech, even if you go for your PhD to the other university or to elsewhere. So this academic mobility is a great opportunity you have in the university. And also the university is very focused into filling the Skolkovo environment. Skolkovo is like the Silicon Valley of Russia. So Skoltech mission is to fill it with startups. Yeah, so you come here, it's best if you have this kind of entrepreneurial mindset, because here you have a lot of opportunities to make your own company. You have the research, you have the resources, you have the connections, you have also the assistance, the mentorship. You have absolutely everything to make startups here.
Great. Thank you, Javier, for the amazing inspiring lecture. We really like it, enjoy it. Thank you for your time and for participating in our events. If there is no questions. So I don't have more to say. That just thank you. I really thank you for your time and the amazing lecture.
Thank you. Okay. Thank you for having me. There's one more text in the chat.
Let me check it. Through images.
It's a big mistake of myself if I forgot to put my email here. Please screenshot it or write it down. Feel free to contact me. I love to help assessoring people just to get their own path, number one. Number two, if you're interested in implementing technology, different kind of technology in agriculture, for instance, or into the electrical grid, you can also contact me. We can cooperate in something very interesting.
Excellent. Please, you can screenshot the email, and if you have any question about the contacts of our guests, you could contact me and ask for their contacts, right? Before leaving, we have another question that says, you believe that there is a relevant difference between young and old university regarding the research approach. What do you think? There is a significant difference in their method on research?
Oh, yes. Yes. How to put it in words? Let's say if you're going to do this one experiment, okay, one, a very well-established university is more conservative, yes? So if you come with a bit of a crazy idea or a not innovative idea, you have a big chance to be rejected. So you don't want that, yes? So when you go to a young university, you will have more chances to have more innovation in your research, yes? What that means, that the professors themselves in these universities tend to be more flexible to make research in different ways. Yes, for instance, my main supervisor, he's a physicist, and his specialty is statistical thermodynamics, and my other supervisor is a genetist. But again, because they're in this environment, they want to be more multidisciplinary, so they come a little bit out of their zone of comfort, and they are able to make very interesting inputs into my work. Yes, so yes, at this level, the flexibility of what you can do is very different. Yes. Now, in the daily aspect, it's also very different, mainly because of bureaucracy. If you are in an older university, you are going to face a lot of bureaucracy. If you get money for a grant, you are going to spend a lot of time. Well, number one, looking for the money of the grant. Number two, filling all the documentation of what did you do with this money. And number three, waiting for the money to be processed so you can buy all the stuff you require. And depending on where you go, this may be very different. For instance, I know that in Germany, to buy stuff is kind of easy. But if you want to buy serious equipment, like to construct, to build a lab, to introduce something new in the lab, that is very tricky. That takes a lot of time in bureaucracy. When you go to the US, a lot of stuff, once you get the money, or once you report the money, what you do in between that is totally up to yourself. So building up your own lab, for instance, or buying the supplies is almost bureaucracy-less. So it changed a lot. In young universities, they tend to be less bureaucratic. So you tend to have more time for research, less time to get money, explain what you're doing with your money.
Excellent. I think that answers the questions that was asked. Well, if there is no any more questions, thank you again. And we really would love to collaborate in future projects. So Javier, thank you, and we look forward to work together.
Yes, I hope so too. Thank you very much for having me. Have a great day, all of you. Thank you.
Good night.
Good
Thanks.
night.